Hey, welcome back. Okay, I still have the same scene open that I worked on the last video. What I'm going to do is I'm going to take a couple of these cubes down here and delete them. Don't need them anymore. I'm going to take this constraint by highlighting the little green dotted line and just hitting delete to get rid of it. So now if I hit play, that one cube just falls down. Okay, and we're still in interactive mode. So what I'm probably going to end up doing is changing that. So let's hit 8 on the keyboard to open up the Explorer. Let's open up the properties for the simulation time control node and switch from interactive to live. Now let's close both of those windows down. Okay, so now we're back to live mode. I'm going to select this cube down here, and under its rotation parameters over here in the MCP, I'm just going to go ahead and hold down shift and right mouse button click the X, Y, and Z channels, and now I'll type in 0 and hit enter. And I'll go ahead and reset this cube right here so that it's no longer rotated in a strange direction there. It's just facing perfectly up and down. All right. So now what we're going to do is look at the different types of constraints and talk about them more in depth and get into those property pages and see what kind of changes we can make. Okay? All right. So if we go over here to the create menu and go back to rigid body, and we go to the rigid constraint tool so we can constrain only 2 objects. Let's tear off this menu by clicking on the scissors icon up here. And now we have this menu to work with, which is great. And we have ourselves 5 different constraints. We have hinge, ball and socket, spring, slider, and fixed. So in this video we're going to talk about each one by one. So the first one's hinge. So what can a hinge be used for? Well, hinge is pretty neat because let's go ahead and select it. And I'll place the hinge in the middle here by left clicking, and then I'll select the first object, and then I'll select the second object. There we go. Let me close the PPG very quickly, and there's the hinge right there. And I can go ahead and move it back more like this. So there's the hinge icon. So what can hinge be used for? Hinge is great when you're trying to lock a couple of objects to a certain axis. For example, the way that a door behaves. You can't grab a door and rotate it in every direction. The door will only swing one way or the other, usually forwards or and backwards, and sometimes not even forwards, maybe just backwards, and it'll be limited to the uh, amount of rotation that it can go ahead and swing in and out of. So that's what the hinge constraint can do. It can imitate things like doors, things like that require hinge type movements. So let's go ahead and hit play. And you notice how the object reacts. It just falls and kind of just follows the orientation here of the hinge. It'll never move side to side. It can only move up and down like this. See that? So let's stop the simulation there. Let's select the actual hinge object in the viewport and hit enter on the keyboard to open up its PPG. So you notice for the hinge we have a constraint tab, a limits tab, and a motor tab. So let's go to the constraint tab. The properties here are pretty simple. Active simply turns the hinge on or off. Visible hides the hinge or makes it visible. And then we have this attached bodies intercollide. By default it's set to off, and what happens is when you use these constraints, you'll notice that when say 2 objects that are constrained like this, sometimes they will not collide with each other. For example, if I take this hinge, move it up here, now I'll take this cube and place it, say, up here like so, and I hit play. I'm going to edit that out of the video, edit that out of the video. Starting again in 3, 2, 1. So what will happen with this parameter is that sometimes you'll notice that the 2 objects that are connected will not collide with each other. They'll just go through each other almost like they were ghosts. So if you see that happening, you could turn on this option here and the objects will intercollide or collide with each other. Then down here we have some interesting parameters. We have a spring parameter, a damping parameter, and a rest angle parameter. And probably the one that you'll notice the most difference with here is the damping parameter. See, if I hit play, you'll notice that this thing swings wildly. It swings a lot, as you can see. If I increase the amount of dampening here, what will happen is that the object almost looks like it's controlled by a hydraulic arm or something like that. Because now, it'll go down real slow. It has a lot of resistance. Okay? Again, like a hydraulic on the I'd say the trunk of a car or something like that. So you can see how increasing it and decreasing this damping makes it more prone to have more movement and more speed, more energy essentially. If you increase that damping, the object won't have as much energy, it'll have more resistance, and it won't move as easily. So you can actually make something look like it's moving in slow motion, or it's trying to move through the water, or anything really that you can come up with. So I'll lower that back down. Then of course we have spring, which will make things behave a little bit springy, for lack of a better term, which just makes them, as you can see the behavior here, it looks almost like this thing has some kind of spring-loaded mechanism that makes it kind of just spring into place, and it has this sort of springy type behavior where it's trying to settle down, but it's still kind of just moving a bit, almost like there was some kind of tension there. Okay, let me hit play again. Now let me show you rest angle. Rest angle controls the angle at which this object wants to rest and find its final resting spot, so to speak. So you notice if I put it down to negative about 132, you notice that it tries to rest at this angle, which is negative 132. If I increase this, now we'll try to rest on the opposite side over here. So the rest angle simply adjusts the area or the angle at which this object wants to rest based on the constraint, in this case the hinge constraint. So let me actually go ahead and place that back down to 0 so it's neutral. And let me lower the spring here. Now let's go to limits. Limits are pretty neat because we can set up minimum and maximum angles at which this object can actually work on that hinge constraint. So let me activate the minimum angle, and you'll also notice that a red line appears on the constraint object here in the viewport. That's to visually tell us the angle at which this object will be constrained. So we can increase that angle, so now the object can actually swing all the way around. Or we can decrease the angle, so now the object cannot go past a certain angle. So we can limit the angle, just like a door. You can't swing a door 360 degrees. It's probably going to hit the door frame or a nearby wall. So if you're doing an animation where you're doing a door that maybe gets kicked in and you want to use this hinge constraint dynamics to simulate that realistically, you may want to use this minimum angle to control the angle at which the door can swing or whatnot, just to make sure that that it looks more realistic. So we can control the minimum angle as well as the maximum angle. So we can turn on the maximum angle, and you can see represented by that red line right there, that red circle, how far or how short that maximum angle goes. So it gives you total control over the hinge constraint and how much it can go ahead and bend or turn to. Then we have a motor parameter. Let me turn off these minimum and maximum angles here. Let's go to motor. Motor's off by default, but we can turn motor on and give this thing some velocity. We can also increase the maximum torque, so we can actually give this object torque. If we start to increase those, you notice the object starts to move by itself, even though it's pretty slight. Let me go back to constraint, and for spring or dampening over here, I'll put it down to the default, which I believe was 6, and I'll lower down that spring. I'll go back to motor. Why is motor not working? Ah, shit. Wait. Hang on. Turn it off. Did you pause the video? Yeah. Okay. Fuck. There we go. Shit. Okay. um, Starting again. 3, 2, 1. So let's go over here to motor, and we have a motor parameter. We can actually turn on a motor, and this can generate power here in the terms of velocity as well as maximum torque here. So velocity will apply velocity to the object, and maximum torque will apply the maximum amount of torque that you can apply to an object. So I'll turn that off for the moment. And let's move on to the next constraint. I'm going to close that PPG. I'm going to select this constraint, and I'm going to delete it. Let's create a different constraint. We already saw ball and socket, so let's move over to spring. So I'll select spring, left click here, then I'll left click this object here and this object here, and there we go. So now these two objects are connected by a spring. Let me close that, and let's hit play. You can see that the object is trying to go through that object, and it in fact is, so we'll have to change that. Select the constraint object, hit enter to open up the PPG, and now we can go ahead and control the constraint here. Let's turn on attached bodies intercollide, and now hit play. Now you notice that the object actually impacts the other object realistically instead of just going through it. So now they're actually controlled by this sort of a spring here. So we can increase the springiness of this, or the damping. Maybe not overdo it. Okay. So there you go. Man. Edit that out of the video. Edit that out of the video. Starting in 3, 2, 1. So if this constraint, again, we have a spring parameter, we have a damping parameter, and a rest length parameter. And if we go to attachment, we can actually control the offsets of the attachment. Body A stands for the first one, body B is for the second one. So in this case, the second one is the lower one. So we can actually offset the actual spring on that object. You can see it's going a little crazy there. So we can actually move the spring over here. You can see you can offset it to the right over here or to the left. So it's in the x-axis. Put that back to 0. Or we can offset it in the y. So now it's going to behave a little bit differently. It's kind of going a little nutty there. So those are pretty much the parameters for the spring constraint. And the main thing to know about the spring constraint is that it works almost like a spring. Kind of like a slinky if you think about it. Okay, now let's close that. Let's select this constraint, delete it, and we'll select a different constraint this time, a slider constraint. So we'll click here in between the two objects, click the first object and then the second object, and there we go. The slider constraint works very similar to the spring constraint. The exception is that it's limited to its area of movement. It works almost like a piston in an engine that goes up and down. It can slide up and down or forwards and backwards, but it cannot go 360 degrees. It can't go more than that one axis, which is either up and down or left and right. But it can't go up, down, left, right, backwards, and forwards like it could with the spring. So here are the parameters for it. Let me go ahead and I'm going to collapse the dynamics initial state down here. These are the main parameters for this constraint here. So if I hit play, you'll see how it behaves, and it's interpenetrating with the other one. So I'll turn on attached bodies intercollide. Now you see that it just snaps there and makes contact at the top one there. Okay. I can go to attachment and I can change the offset. So for example, if I wanted to, I could offset this by this amount. And now it won't reach the top because it's offsetted. Okay. I can also control the limits of the minimum extension and the maximum extension. So let's go to the minimum extension here. I can increase that, say, to 10. And now it won't go past that point there. It's limited to a value of 10 in the minimum extension. So I'll turn that off. Then we also have a motor, which we can activate. And we can increase the motor velocity here and decrease it. So if you wanted to animate this as a piston going up and down, say if you're doing an animation of an engine for a vehicle or something, you can animate this motor velocity so it goes up and down, up and down. Okay. You can also increase the maximum force that piston can exert, or the torque. Well, in this case, it'd be the force. Okay. So I could turn that off, and there we go. That's the slider constraint. Very simple to use. So I'll select the slider constraint, delete it, and I will select the fixed constraint. And we'll go ahead and take the fixed constraint and we'll place it here. Then we'll select the first object and second object, and that's it. Now, if I hit play, nothing's going to happen. The fixed constraint works almost like a metal support bar that's welded from one object to the other. So to truly see how this object works, I'm going to have to change my setup here. Let me close that, and I'll close this menu here. I'll select the passive rigid body, go to modify rigid body, edit rigid body, and I want to change this object down here from a passive or from an active to a passive. So I'll uncheck the passive parameter to make it active. So now when I hit play, both objects fall. The next thing I'm going to do is I'm going to go ahead and create another cube. I'm going to flatten it down, just kind of widen it out like this to behave almost like a table, so to speak. Move it down here. I'm going to turn off the grid by hitting G on the keyboard there. And with this cube down here selected, I'm going to go to create rigid body and set it up as a passive rigid body. I'll close that. Now when I hit play, the object falls. So this is fixed. The fixed constraint holds the objects in place. Doesn't allow them to swing around, doesn't allow them to rotate or do anything like that. So if I take these objects and say I rotate them, I'm going to turn on global mode here, and I'll turn on COG, and I'll rotate them like so. If I drop them, they almost fall down like a hand weight. So you can see how they just fall and just fall together, and they keep their distance apart. So it constrains them almost like this, like a bolt or some kind of support beam or something like that. Some kind of hard, long object that just connects the two objects together, like so. So it's pretty simple. The fixed constraint is pretty simple, pretty self-explanatory. Let's select the constraint, hit enter to open up its PPG. And it really doesn't have any parameters except for these parameters, the active, visible, and the attached bodies intercollide. Pretty much because there's nothing else that the fixed constraint can do. It just hooks up one object to the other. So you can think of it almost like a nail pinning down a piece of board to the floor. It's not going to move. It's just going to be pinned down, and it's not going to go anywhere. So that's how this fixed constraint works. So as you can see, we went through all the constraints. There's no more constraints left to talk about. So that's going to do it for this video. That covers all the constraints in XSI, how to use them, and we covered the parameters so you can understand the benefits of using which constraint under which circumstance. So I'll see you in the next video.